Welcome to this CHEMCAD Data Maps tutorial, where I'm going to teach you to use CHEMCAD Data Maps to efficiently record simulation data in Excel. The objective of this tutorial is to have you understand how to use CHEMCAD Data Maps correctly to perform these simulations in CHEMCAD and then record the relevant data that you want in Excel. This will help you to improve efficiency in data acquisition from your simulations, and process analysis, and also in process optimization and determining which variables that you really need to pay closer attention to. The audience for this tutorial is designed for chemical engineers of any education level who'd like to learn more about using CHEMCAD data maps as a tool for chemical process design and analysis. Now, it is important for you to have Excel basic knowledge, CHEMCAD process design basic knowledge, knowledge of chemical separation in a distillation column, knowledge of chemical solubility data, and also of thermodynamic models. The materials that you might want as you're going through this tutorial: if you are going to complete this tutorial on your own, you'll need a laptop computer with Windows operating system, with CHEMCAD version 7 installed and Excel software version 2016 or newer. Current license to access CHEMCAD, and you can update that license through ChemStations if it's not up to date. You also will need internet access anytime you're trying to connect to CHEMCAD to validate your license. You need an internet connection. If you need to brush up on some of your background knowledge before we get too far into this tutorial, here are some places I suggest you look. CHEMCAD Basics by ChemStations Incorporated. These are very good, thorough videos if you want to learn all there is that you can do in CHEMCAD Basics. There's the CHEMCAD Essentials Part 1 and CHEMCAD Essentials Part 2. We'll be working with distillation columns, so you could look at that one if you need more information on that. Excel Basics by Technology for teachers and students is also really good. The Beginner's Guide to Excel, an Excel Basics tutorial. If you want to learn a little bit more about distillation columns, AICHE Academy is a good place to go. They have a video called Distillation Basics on how a distillation column works. All of these videos can be found on YouTube if you just search those title names. Now, on to the tutorial. We will start out by opening Excel and select a blank workbook. Go ahead and double click. Sometimes you may be working on a project with multiple sheets open in Excel. So I'll show you how to make sure your information from CHEMCAD only goes to a specific sheet. We're going to rename sheet 2, just for convenience, as CHEMCAD. And later we will tell CHEMCAD that that is the sheet that we want it to map our data to. Next, go up to File and Save. Save it in a location that you'll easily be able to find it later and under a name that you can easily identify. Do not X out of your Excel at this point. You just want to come up here and minimize it for later. Now we are going to open CHEMCAD. If you have trouble opening CHEMCAD, make sure that you're connected to internet to authenticate your license. And if you don't have a license, you're going to need to get one before you can go through with this. So open a blank workbook as I have here. If yours is not yet open, go ahead and click on this icon. We're going to start by saving this document. Make sure that this palette appears on the right-hand side of your screen. If the palette does not display when you open up your screen, follow these steps. Go up to View, check Palette, and palette should now display on the screen. We're going to add a distillation column, so scroll down in the palette until you find tower. This one right here. There's several to choose from. We'll just choose the regular tower for today and drag it onto the blank worksheet. Scroll back up to the top of the palette and add the feed stream and product stream. Connect the feed stream anywhere on the column's left side to one of those blue dots, and then drag two product streams, one for the distillate and one for the bottoms. Now that your distillation column has been set up, we need to select the chemicals that we're going to add to our distillation column. So come up here to Thermophysical, click on Select Components. Use the search bar highlighted in red to add the components butane, hexane, and pentane. As soon as you select OK, the thermodynamics wizard will pop up. We won't worry about this now, just select OK. The next pop-up shows that SRK is your thermodynamic model that they've chosen. We are going to change this in a minute, but select OK for now. The thermodynamic settings prompt will appear. Underneath Global K-Value Model, it should say SRK. Click this drop-down menu and change that to NRTL. Then select OK, and on the next prompt that appears, also choose OK. Now we are going to open CHEMCAD. If you have trouble opening CHEMCAD, make sure that you're connected to internet to authenticate your license. And if you don't have a license, you're going to need to get one before you can go through with this. So open a blank workbook as I have here. If yours is not yet open, go ahead and click on this icon. We're going to start by saving this document. Save it to desktop as CHEMCAD tutorial. Make sure that this palette appears on the right-hand side of your screen. If the palette does not display when you open up your screen, follow these steps. Go up to View, and the palette marker here should appear. Check it, and then the palette should now appear on your screen. We're going to add a distillation column, so scroll down in the palette until you find tower. This one right here. There's several to choose from. We'll just choose the regular tower for today and drag it onto the blank worksheet. Scroll back up to the top of the palette and add the feed stream and product stream. Connect the feed stream anywhere on the column's left side to one of those blue dots, and then drag two product streams, one for the distillate and one for the bottoms. Now that your distillation column has been set up, we need to select the chemicals that we're going to add to our distillation column. So come up here to Thermophysical and then select Components. There are many components to choose from. You can scroll through it to find the components that you need, but I find it easier usually to search in this bar for the component I need. Since butane is one of the components we need and is automatically appearing, you could just click on that one here and add it. Another of the components that we need is hexane, which I'm typing now on the bottom search bar. And I can click on it and click this arrow to add it, or I can double click and it adds it as well. For the last one, find pentane. Now, you could scroll down this bar to find it, or you can type it in this search box here. Be sure to select the correct pentane. We've got isopentane and pentane. We want just pentane. Then select OK. This will automatically appear once you've created a new system. Go ahead and just press OK for now and ignore the rest of those settings. This indicates the type of thermodynamic model it's selected for us. It's chosen SRK. We're going to change that. So instead of having an SRK model, instead of having an SRK model, we're going to choose an NRTL model. So there it is. Go ahead and click that. There are no other adjustments that need to be made on this slide. So press OK. This just verifies the thermodynamic components that it's going to be using for calculations. You can verify those as well. Pressing OK. If you're using a different system of different chemicals, you might have different thermodynamic systems that you would use depending on the properties of those chemicals. But for this system, we'll choose NRTL. Now we're going to set up our feed stream conditions. Click on this arrow for the feed stream going into the column. We can name it if we want. I'll call it feed. Specify a temperature. I'll choose 80 degrees Fahrenheit. PSIA 14.7. So we're just at atmospheric conditions. Butane, I am just going to select 100 pounds per hour for all of these components. Then you can flash the stream and it'll calculate the other values, as long as enough of it is specified. Select OK. Next, we need to specify the column. Double-click on the distillation column. First, you're under the General Editing tab, and you want to, anywhere there's a green, put in some important information if it's highlighted green. So for the number of stages, I'm going to choose 10, and for the feed stream, I'll just choose 3. Next, our tower needs to have further specifications. So click on the Specifications tab. For the condenser, we are going to specify a reflux ratio, R over D, of 2. And for the reboiler, we'll choose a bottom component fraction recovery of 0.98. For the heavy component, which I happen to know is hexane. If you didn't know that that was the hexane was the heavy component, you could run this simulation and with random specifications and figure it out based on which component is going to appear more so in the bottoms than it is in the feed. Now we will specify the feed stream by double-clicking on the feed arrow and inputting the following data. Stream name, feed, temperature, 80, pressure, 14.7, and down to the bottom, butane, 100, hexane, 100, pentane 100 pounds per hour. That'll give us a total flow of 300, which it should automatically solve for. Now, if you choose flash at the top left, it will solve for your vapor fraction and enthalpy automatically. Select OK, and now we are going to work on our unit op specifications. So double-click on the distillation column. Under the General tab, type in 10 for the number of stages and 3 for the feed tray location for stream 1. Then go on to the Specifications tab, where we will be changing the condenser mode specification first. Choose reflux ratio, or R/D, on the drop-down menu for the condenser mode specification and set it equal to 2. Next, for the reboiler mode specification, on the drop-down menu, choose bottom component fraction recovery. Set that equal to 0.98 for hexane. Then go ahead and select OK. Now we're ready to set up a data map. Go up to Tools. Now, this is your blank data map. The first thing you want to do is note the Excel workbook path. That is going to be the Excel that we saved earlier. So go ahead and click the Browse button, find it, and select it. Put it there. Now, Excel worksheet name. Your workbook could have multiple sheets. So that's why we named one of ours CHEMCAD, so that it knows which worksheet to send the information to. Now come down here to Map Rules. You have the option of sending information from CHEMCAD to your worksheet, or send information from your Excel to CHEMCAD. We're going to choose to worksheet and choose either a stream or a unit op here. We're going to choose a unit op. Now, we only have one unit op, but we need to specify its object ID, which is 1. So make sure you include that. Then par ID, this is going to be which parameter. So we're going to send how about the condenser duty, and send it to worksheet cell A1. Now we can also send information to CHEMCAD from our Excel worksheet. And how about we change stream 1, which is the feed stream, and we'll change its temperature, and we'll put that information in B1. Make sure you save your data map before moving on to the next step. Go to select File and Save. Now that your data map is complete, go over to this bottom left-hand corner and select the CHEMCAD tutorial page, because now we have to define execution rules for our data map. So come back up to Tools, highlight Excel Data Map, and then select Execution Rules. You'll now need to click that red box to select your data map. Select Data Map 1, which is the only one that should be available to you, and then click OK. If you had multiple data maps, you would have to select which one you wanted these rules to apply to. So now you're going to change the before simulation and after simulation rules that correspond to that data map. Before the simulation, go to CHEMCAD, and after the simulation, go to the workbook. Then select OK. Pull up your Excel file real quick, and in the space for B1, go ahead and type in 80. That corresponds to the temperature of feed stream 1 that we are sending to CHEMCAD before the simulation. Now come back over to CHEMCAD, and we can finally run our simulation and see what happens. Popping back over to Excel, we can see that in A1 we have a condenser duty that was calculated as negative 0.093. You'll notice that B2 did not change because it is only sending information to CHEMCAD before the simulation is run, whereas A1 is taking data from CHEMCAD after the simulation is run. You can run this simulation again and change B1 to, I don't know, 100 degrees for the feed stream and see if your condenser duty changes as a result of that and would be reflected in A1. In review, what we've covered is how to open an Excel file and save it in an appropriate location and name that you'll recognize. Also remember to minimize that Excel file. Then we went through CHEMCAD and the process setup, putting the distillation column and the feed and the product streams and your components and your thermodynamics into CHEMCAD. Then we went to the data map slide, data map tab, where you needed to recall your Excel file name and your sheet name to map to. Then we input parameters that we wanted to map from CHEMCAD to Excel, and we also chose parameters that we might want to map from Excel to CHEMCAD. It goes both ways. Then we saved our data map. Anytime you make changes on a data map, remember to save it. Then we went back to our CHEMCAD process setup tab and we opened up the data map execution rules, and remembering to select the data map that you want, and then specifying if you want something to happen before or after the simulation is run. Then we ran the simulation and found our values in Excel. In conclusion, this was all about data mapping from CHEMCAD to Excel, and I wanted you to get the basics down because it's a really useful tool for optimizing processes. You can record simulation data in Excel and tabulate it. You can also update your simulation parameters in Excel and then map them to CHEMCAD with the data mapping software. Finally, you can analyze the results of multiple simulations if you are to copy and paste that data in Excel so it doesn't get written over by your next simulation. Something to make this even more useful is to implement Excel VBA, so you don't have to copy and paste one simulation's data over so it's not rewritten in Excel. You can implement VBA, Visual Basic, and run and record multiple simulations at once, and that's what makes this tool really powerful. So I recommend you learn that next if you haven't learned it already. And that's all I have for you guys. I hope this was entertaining and educational. If you have any questions, feel free to ask.